Okay, g'day all, welcome to another video. So we're exploring AVX512 in this video. This will be a three-part series, and in this video we're going to look at three different ways that you can code AVX512 in your own projects. So we're going to be starting with AVX512 VCL, and then we're going to look at intrinsics, compiler intrinsics, and the final way that we'll look at is a little bit of hand-coded assembly language. You can actually do all three methods of AVX512 programming if you want. Yeah, you can do all three in one project if you want. Okay, so let's just get started with AVX512 VCL. I'll leave a link down below in the video description so that you can visit the VCL GitHub and get the library yourself. So the library is all free. It's a SIMD vector library designed to make your code fast using SIMD instruction sets, but it's also really convenient to use. Yeah, very easy to code. Grab the library, unzip it somewhere. I've actually unzipped mine on the desktop just here in a folder called prog. You'll see that the library is just a bunch of headers. It's a few CPP files, a license, changelog, that sort of thing. Yeah, but just download the library from GitHub, the latest version, and unzip it somewhere onto your computer where you will be able to find it later. Okay, but the code, let's get started. So we'll make a new empty project. You can, of course, add this sort of stuff to existing projects if you want. I might just call mine AVX512 examples. Yeah, something like that. Then we'll click create. So in order to use any of the methods that we're about to do with the AVX512, you probably want to change over to x64 first. So that's up here in the configuration manager, x64. We don't want to make 32-bit apps here. Yeah, they're really very limited in a lot of ways. So x64 is the way to go. The next thing that we want to do is add a CPP file. So I'm just going to right click on my solution name and click add and new item. You're going to click CPP file and Visual C++, and I might just call it main.cpp. The reason that we add a CPP file so early is because we need to come up here into project and go into the properties. We want to change the properties, but we need the C++ properties to be available over here. Yeah, so if you don't add a CPP file, then the C++ properties aren't available. All right, but to use the VCL, we've got to, first of all, we've got to check the language standard. Set that to C++ 17. Yeah, it's probably on default or something like that. Well, you could set it to something more modern if you want, if C++ 20 has come out. Then if you come down here to VC++ directories, we've got to tell Visual Studio that the path where the VCL files were extracted to, we've got to tell Visual Studio that that is a header folder, so that it can search and find the library. So that's just here in the include directories. So if you just select VC++ directories and then include directories, you can come over here and click the little arrow and edit, and click the new folder button and the ... I don't know why you have to click so many buttons. It's not particularly user friendly. Okay, but I extracted the folder to my desktop and then prog and then AVX512 VCL. So we'll just select that folder. OK, and apply. You should click apply between changes every time you're messing around with the properties. And the reason for that is sometimes little glitchy bugs will delete a change that you've made. I swear, it's really irritating. But anyway, there's no library directories or anything like that. So let's just come down here to C++. So another couple of things. The VCL will use intrinsics. It will generate instructions based on the instruction set that you specify. So we have to come down here to code generation. And you see here in enable enhanced instruction set, what we want to do is select AVX512. If you have a CPU that's not AVX512 capable, then you'll still be able to compile AVX512 programs, but you just won't be able to run and debug them. So you can try this stuff out to a degree, even if you have a different CPU that's not AVX512 capable. All right, but to use the VCL, we have to specify an instruction set. And since this is an AVX512 tutorial, let's just select that one, shall we? It's often a good idea here for speed too, if you change the floating point model, but you don't have to do that. I'll just change it to fast because I don't like waiting. I think that's about it. So if we just hit OK, we'll be just about ready to program some AVX512. Oh, it is difficult to type with this microphone in the way. Include IO stream. Include vector class.h. Okay, so IOStream is just a standard C++ file, but the VCL header the main header is called vectorclass.h. I actually made a video, or a couple of videos a while back, on the VCL and how to use it, where we went into a little bit more detail. So if you want a bit more information, a little bit more detail on the VCL, I'll leave a link up above to those videos so that you can have a bit of a watch. We did a bunch of fun things. There was a bunch of fractals and a lot of kind of graphics things and speed tests. It was good fun. And I'll also put a link down below so that you can watch those videos if you like. But the data type for the VCL, so all we're going to do here is just we're just going to add vectors of 8 doubles. He holds up 4 fingers confidently. Well done, ya. Okay, A equals 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0, 8.0. With a little comma there as well. Okay, so we're just making little VCL vectors just here. So these will be stored in AVX512 registers. That's because we set the instruction set to AVX512. So 512-bit registers, or the AVX instructions, can operate on 8 double precision floats at once. So we just set up 3 little vectors here, A, B, and C. And the A and B vectors both have just numbers in them, 1, 2, 3, 4, 5, 6, 7, 8. And the C vector at the moment is blank. To actually do some arithmetic with AVX512, if you're using the VCL, it's really, really simple. I mean, this is really the benefit of the VCL, just how convenient it is and how easy to read the code is when you use it. Oops, I missed out an equals. So that, just there, C equals A plus B, just using standard operators, that's actually going to add the A and B vectors and store the result in C. So what we're going to get here is 8 little element-wise additions. 1 plus 1 will be stored there, then 2 plus 2 will be stored there. We should end up with 2, 4, 6, 8. Yeah, 2, 4, 6, 8 in the C vector. Let's just print it out, shall we? Well, I is less than 8, I plus plus. STD, C out. C, I, STD, and all. Yeah, so you can use the array brackets to access elements of a VCL vector. So what we should get here is in C, the results should be 2, 4, 6, 8. Let's just have a bit of a look. Yeah, there you go, 2, 4, 6, 8, 10, 12. So that addition has occurred using an AVX512 instruction. In theory, I mean, we're in debug mode at the moment. I don't really know how it's happened. So we've also got other operators, minus, divide, and multiply. A whole bunch of really powerful operations that you can do with VCL. And I will leave a link down below in the video description to not only the library, but also the manual. Yeah, so if you do get the library, you really need the manual as well, since it kind of explains things. Yeah, but really convenient way to program AVX512 in your applications. Okay, so that is the vector class library. Let's move on now and have a look at how you would do the same addition, or much the same addition, using compiler intrinsics. So the first thing that you want to do is include intrin.h in your file. So the data type for a vector holding 8 doubles, AVX512 vector in intrinsics, is underscore M 512 D, I think. Yeah. Okay, so there we go. So we've got the same 3 vectors defined as before, except with intrinsics, you can't use high-level things like operators. This is not going to work just here. With intrinsics, it's a little bit lower level, a little bit more confusing. You actually have to type the instruction that you want yourself. So it's add underscore PD. Yeah, AB. There we go. You also can't access elements using the array notation in intrinsics, so we might just cheat a little bit. Now, this is not a great way to access the elements, but I'm just going to cheat a little bit. Just This is probably not a recommended way to do this. Usually you'd want to, I guess, copy the vector to an array somewhere and then print it out using the array notation. Yeah, but for this little demonstration, we just assume that this is safe. Generally speaking, it's fairly safe anyway. I mean, these vectors are contiguous RAM somewhere. Okay, there we go. So our C vector has 2, 4, 6, 8, 10, 12, 14, 16, exactly the same as before. Now this underscore MM512 add PD, that is an AVX512 intrinsic. And if you type something like underscore MM and then 512 underscore, you'll see all of the different AVX512 intrinsics that you can perform. There's lots, there's a lot. Yeah, like we said, it's a huge instruction set. Okay, so that's AVX512 using Agnifog's VCL and using intrinsics. Let's have a bit of a look at assembly. Okay, so what I might do in the assembly demonstration, we might have to change things just a little bit. These will just be arrays. Okay, so for the assembly version, you actually have to include a separate assembly file. And before you include an assembly file, you have to set up the build customization so that Visual Studio knows to hand your assembly file to MASM, the macro assembler, or NASM, the net-wide assembler. So we right-click on our solution over here, and we come down here to Build Dependencies. Then we select Build Customization, and we select MASM just there. I've actually got NASM installed on this computer as well. Yeah, so you could click that if you want. There's options. You don't have to go with MASM. Anyway, the syntax would be slightly different for NASM. Yeah, so I'm only going to be showing MASM today. But so the next thing that we might want to do is set up our assembly file. So I'm going to right click on my project just here. We'll come down here to Add, New Item. We're going to select CPP file, but we're a bit lower than CPP just here. We're talking ASM, bruss. Okay, so the item that you select is a code file, CPP, but, and this is kind of crucial, you have to give it a .asm extension. So I might call mine AVX512 test.asm. Yeah, something like that. The reason that we do that is so that MASM gets handed this file to assemble. Yeah, we don't want to try and compile this with the C++ compiler. Anyway, we click Add. So a lot of this stuff is just for people that aren't familiar with the channel. I realize that some people have been watching this channel for a while and they've probably seen me do exactly that 800 million times. I don't want to miss anybody out. Anyway, let's make a new function, a proc, a procedure. So .code, yeah, this is the code segment just here. We're going to call it AVX512 test, and it's a proc, and she's going to return at some point AVX512 test, and end P, and end. Okay, so what I might do is we won't really be talking about assembly in general. Let's just show how to do this rather than explain kind of why it works, I guess. We don't have time to go in depth in assembly, but there's lots of videos on this channel if you're interested in that topic. So we're going to make a function that returns nothing. It's called AVX512 test, and we'll say that it takes a double star RCX, a double star RDX, and a double star R8. Okay, so we're going to be passing our three little vectors just here. It's a little bit awkward in assembly, but we are going to have to pass these as parameters. And they're going to be passed in RCX, RDX, and R8. Okay, so if I just put another note at the top here, these are comments just here. Yeah. This one just here is the C array. RDX is going to be the A array, and R8 is going to be the B array. Anyway, this is how you call an AVX512 instruction. It's not really how it works. It's not really about the syntax of assembly. Just how do you call one? What we might do is vmov. Vmov. U, PD, ZMM0, ZMM word, PTR, RDX. That right there is a AVX512 instruction to read from RAM into one of the registers. And the register that I've supplied just here is the AVX512 register ZMM0. Yeah, so what this is going to do is read the 8 doubles from the A array, which is just here. It's going to read those into ZMM0. Then what we're going to do, mov, actually we don't need to mov. we can just v add pd, ZMM0, ZMM0, and ZMM. Something like that. And vmov, upd. Okay, so this middle instruction just here, vaddpd, this is the AVX512 instruction that actually performs the 8 additions in SIMD. Yeah, so this instruction just here is going to add these doubles to these ones. And then the next instruction, vmov upd, or move aligned packed doubles, is going to save that result that we just computed in ZMM0. It's going to save it to RCX, which is the C array. So if we just save that for a second and we come back over here to C++, we do actually have to declare our function. Normally all of this declaration would be split into a header or something like that, and you would include your asm.library a little bit differently. But so to declare it, we say extern void, and what was the name of the function? AVX512 test. I'll just copy that. So you do have to put C there too. Now the C just means, and that's an uppercase C. The C just means that it's the C colon convention. We don't want C++ mangled function names because it's just awkward. Yeah, so we'll just use the C colon convention. Anyway, double star A, double star, wait a minute, that one's A, double star B, and this first operand is C. Okay, so once we've declared our function, then we can call it down here, AVX512 test, and C, oops, it's a capital C, A, and B. Oh, that's a capital as well. And we should get the same result as before. We should just get 2, 4, 6, 8. Let's have a look how we go. Yeah, there you go. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so one last thing that we might do, just while we're here, we might actually just step through this one step at a time. So if I just put a breakpoint there on this little assembly bit just here, we've got the disassembly over here. What we can do is actually add a watch to the AVX512 register, ZMM0. We just go add a watch. So what you'll see just here is all of the different data types that the bits of ZMM0 could be interpreted as. So we know that it's actually storing float 64s. Yeah. So if we just step over this line, what you'll see is that mov upd moved 1, 2, 3, 4, 5, 6, 7, 8 as doubles into ZMM0. And that is the A array just here. Yeah. And then the next line, what you'll see is that the other array, or the B array, is actually added to it. What I might do is just change the values of the B array a little bit. Let's just change them to 5. Yeah, it's a little bit unclear exactly what's happening there. What we could also do is just vmov and upd. The upd means unaligned packed doubles. So what we're saying there is that we don't know that the address of those arrays is aligned or divisible by the size of an AVX register, which is 64 bytes. We don't know actually, so we might as well use unaligned. Yeah, so we could do it like this if we want. Instead of adding from RAM, we could add the two registers together. So read the A array into ZMM0, read the B array into ZMM1, and then add the two together using vaddpd, and then store the result in the C array. Let's have a bit of a look at this. Yeah, there's lots of ways to do this sort of stuff. Lots and lots of ways to do it. What am I doing? Okay, so the ZMM1 array, we'll add a watch to that. So that should load a bunch of 5s since we just changed it. So at the moment it has negative nan. What? At the moment the ZMM1 array doesn't have much in it, but if we step over that line we see that the B array, which is filled with 5s, has been read into the ZMM1 register. And then of course the vaddpd will actually change the ZMM0 array. So if we have a bit of a look at that, there you go. And it just added 5 to each of the values from the A array. That's just 3 ways that you can program AVX512 in your own projects. Interesting stuff. So in the next video, the final video, we're going to go really low level and talk about the different mechanisms that are in AVX512. Interesting instruction set. It really is. Anyway, for now, I just want to say thank you very much for watching. I hope that was interesting and helpful, and I hope you have a really good day. I might give my project a name. I'll just call it like AVX512 examples. X-Mapples, I'll call it.